Alright, good day everyone. So welcome back to my YouTube channel, Kasiligan Vlogs. And today we will be talking about Morgan's Law for statements. And this is mathematics in the modern world. So the Morgan's Law for statements for any statements P and Q. So negation of P or Q is equivalent to we have here negation of P and negation of Q. Or this is negation of P conjunction of negation of Q. And negation on this one, negation of the statements P conjunction of Q or and Q is equivalent to negation of P disjunction or negation of Q. So this one. So let us prove first. This one is negation. Okay, first let us prove here if we're going to make a table for this one. So if this is P, Q, there's two statements here, we will prove that this statement is are equal. Okay. So this one P, Q, so therefore this is negation P disjunction of Q. Okay, let's first have this true, true, false, and false. True, false, true, false. So you can make a table out of this one. Okay. Okay, so this one is first, we need to get the P and Q. So P or Q. So this one is, we will copy true, true, false, and false. This one is Q, T, false, T, and false. True, false, true, false. This is one. The answer for this one is one of the statements true. The answer is true, so therefore it's true, 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 and false. So negation of this one is false, 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 true. So this is the answer, the negation. If we're going to make another table for this one to prove this, so let's continue here. P. If this is negative P, uh, negative negation of Q. If this negation of P, which is false, false, true, and true, and this was negation of Q, which is false, true, false, and true. So this one is conjunction, so therefore this is false, this is false, this is false, and this is true. And this one is equivalent to this one. So therefore they are equal. Okay? If we're going to make a table out of this one. Let us prove this one. Negative P. Let's just continue here. Okay, negative or negation. So negation of P conjunction of Q. Okay, negation. First, we need to have first the statement P. This is true, and this is true, this is false, and this is false, and this is true, this is false, this is true, and this is false. Conjunction, so therefore this is true, this is false because one of the statements is false, this is false, and this one is false. And negation of that one is false, and this is true, this is true, and this is true. So this is the answer for this one here in the sign. So let us prove that this statement is equivalent to this statement. Okay, negation of P, disjunction of negation of Q. If the negation of P is, the answer is false, we need to negate this one, and false, true, and true. And negation of Q, which is false, true, false, and true. And disjunction of this, if one statement is true, the answer is true, or this disjunction is true. So this is false, this is true, and this is true. So therefore, these statements are equivalent statements. Okay, we will make a table of this one as our truth value. Okay, so therefore these statements are equivalent statement according to De Morgan's laws. De Morgan's laws for statement for any statements P and Q. So let us apply this one into this. Use this Morgan's law to restate the following sentence in equivalent form. So we have here an equivalent sentence. We need to equate this one into its equivalent statement. So what if the first is this one? Okay. The first statement is here, and the second one is here. It is not true that I graduated or I got a job. So we will have first, it is not true. So we will first have P statement is equal to I graduated, and Q statement I got a job. It is not true, so I mean to say it is not true P or Q. So what is the equivalent to this one? So the equivalent to this statement is negation of P. Okay, let's check. Or this is or. Based on the statement, this is negation. This is not true that I graduated, or this is or disjunction, or I got a job. And P and negation of Q. So therefore, these statements, if we will rephrase this one, is not true that I graduated or I got a job. So negation of P or Q is equivalent to negation of P and negation of Q. So therefore, this statement, if we're going to have this, we could restate this one as I did not graduate, because this is our P. I did not graduate, and I did not get a job. So this one, we could restate this in this form because these are these statements and these are equivalent statements. So I did not graduate and I did not get a job. Next, it is not true that I'm going to dance and I'm going to the game. So and it is not the word and here. So we will make use of this statement. So okay. It is not true. Let us have first our P is equal to I am going to the dance. And our cue is I am going to the game. If the statement is it is not true that P and Q is equivalent to, because and I'm going to the game. What is the equivalent to this one? This one. Okay? Remember this one, negation of P or negation of Q. So negation of P or negation of Q. So therefore, we could restate this as I am not going to dance. So what is the negation of this one? I am not going to dance. So we can have that one, I am not going to dance, since the negation. So this is I'm going to dance, because the P is I am going to dance. So therefore the negation of this one is I am not going to dance, or since the negation of I'm going to game is I am not going to the game. Okay, so this is the statement, the Morgan's law statement to restate the sentence in equivalent form. So try this one at home. Make use of this Morgan's laws to write the given statement in equivalent form. She did not visit France and she did not visit Italy. And it is not true that it rained or it snowed. Okay? So thank you so much for listening, and God bless. I hope you learned, and just comment your answer if you want, if you access this YouTube channel.